Hello, Algebra 2 students. I am looking at, for Mr. Fry, this lesson 24, solving systems using tables. And let me get this a little bit closer. So what we got to do is we just got to plug in these x values to get these y values and just see where they are going to be the same. One little trick on your calculator, if you want to do this, if you have a calculator like this, and you get more complicated ones like number 7. I'll show you number 7 on the calculator. What I like to do is I like to put this part of the equation in the calculator and then just substitute my x value in every time to figure out my y value. So, and I put that x value in parentheses. So I go into the parentheses in the calculator and I just change that number. You know, I change it from 0 to 1 to 2 to 3 to 4, and I just keep doing that. It just makes things go quicker. So in other words, like this one would be, so number 1 would be 4, parentheses. My first x value is 0. I put back parentheses and then minus 3. So then I hit equals. Now all I have to do is hit the back button and then change it to 1. And then I go hit the back button and change it to 2. And then hit the back button and change it to 3. And so on. And it's just an easier way so you don't have to type it in every single time, okay? So doing that, you see my, my chart for my input-output table, I guess I should call these instead of T-charts, or, you know, I'll show you the T-chart for number 7, but this would be a input-output table. And you see where they're common, that's where these lines are going to cross. This is a linear equation, These are where they're going to cross at 3, where they're going to intersect at 3, 9. So 3, 9. For number 3, you should be finding at 4, 6. Now I just started with 0, and I lucked out. You know, these, I'm imagining all of these are going to be, you know, 0 through 5 or whatever, and you're going to find it. You may have to go a little bit further if you're not finding it. Number 5 was 3, 2. And then for number 7, we have Michaela put $212 in a savings account at the beginning of the year. At the end of each month, she subtracted 12 from her account. Matthew put $30 in his savings account, and at the beginning of the year, and then at the end of each month, he deposited 14 into his account. Let X represent the number of months which have passed, and Y represent the number or the amount in each savings account. So first of all, write an equation to represent the amount that Michaela's savings account. So this one would be your A right here. This is your A. I went ahead and did it on a separate sheet of paper because I didn't have a lot of room. I didn't want to put it on the back. I wanted some lines, so I did it on a separate sheet of paper. Matthew's right here, this would be your B. He had the 30, and then he deposited 14 each month. This is Michaela. She had 212. She subtracted. She withdrew $12 each month. Okay, so this is my B. And then C, make an input-output tables. So here's my input-output tables. And this is where that whole calculator thing came in handy. So like I did, let me clear this. So 212 minus 12, and then I put my 1 in there. I hit equals. Then I went back and I put my 2 in there. Hit equals, and I went back and put 3 in there, and so on and so forth. It just makes life a lot easier, makes it a lot quicker if you have a calculator that you can do that. So this is the table for Michaela's, and this is the table for Matthew's for the first 8 months. Okay, and then it asks for D. So this is your C. Both of these tables are for C, and then your D at what? When will Michaela and Matthew have the same amount in their accounts? Well, it looks like it's going to be on the 7th month. Okay, 7th month. So it's going to be 7, and it's going to be 128. Okay, and that is it for that one. And I'll get your one up for you as soon as possible for tomorrow. So good luck.